All right, so here we go. We're going 2-4B at home practice. If you're wondering why there's no 2-4A, there's no 2-4A at home practice in the book. So 2-4B at home practice problems. The first problem says solve the following system of linear equations graphically. Now we know what that means. That means basically we're going to take these two lines and then graph them each on this plot and then see where they intersect. That point of intersection is going to be the point that makes, when you plug it into the first equation, that's going to be true, and the point where when you plug it into the second equation, you get a true statement as well. So here are our two lines, 3x minus y equals 5, and x plus 2y equals 4. Now you can graph each one of these individually by either using the slope-intercept form of the line, like we did in section 2.2, or you can use tables and plotting points like we did in section 2.1. What I'm going to do is I'm going to utilize the techniques of section 2.2. Now the first thing I like to do is separate these lines so that we can solve each one for y, meaning that we get it into slope-intercept form. So in order to do that, to get this first one into slope-intercept form, I'm going to have to subtract 3x from both sides. When I do that, I end up with negative y is equal to negative 3x plus 5. I'm almost in slope-intercept form. I need to just divide by this coefficient of negative 1. When I divide both sides by that coefficient of negative 1, I get y equals 3x minus 5. So that means that the slope of this line is 3, and the y-intercept of this line is 0, negative 5. So I could go and graph this line right now. In fact, that's what I'm going to do. So again, 0, negative 5 is the y-intercept. So I plot that on the line. 0, there. And then a slope of 3 means I need to go up 3 and over 1 to get to my next point. Up 3, over 1 to get to my next point. Continue on that pattern. Up 3, over 1. Up 3, over 1. Now, again, like I said in class, you want to make sure that you extend this as long as possible, just so you know that you end up with the actual line itself. So what I'm going to do is I'm going to draw this line. I'm going to omit the arrows right now off of it, but you could, well, actually, let's go ahead and just draw the arrows just to say that this pattern does in fact go on forever. There we go. So that's the graph of the first line. Now that's just the first line. The second line, x plus 2y equals 4, I'm going to do the same thing. I'm going to take and, well, get this one into slope-intercept form. That requires me to subtract x from both sides. So I'm going to get 2y on the left and minus x plus 4 on the right. To get into slope-intercept form, there's one more step I need to do. I need to divide both sides by 2. We end up with y is equal to negative 1/2 times x plus 4 divided by 2 is 2. Again, each time when I divide that 2, divide this term by 2, divide second term by 2, divide this third term by 2. Divide all those terms by 2. So that's what we have. And what that means is that we have the slope, whoops, of negative 1/2, and my y-intercept is the point 0, 2. So that's what we'll do. We'll go ahead and graph this line now that I know the slope and the y-intercept. So I go to 0, 2. It's right there. Slope is negative 1/2. That means go down 1 and to the right 2. Down 1 to the right 2. Down 1 to the right 2. And so you see the pattern here. Now, on the test, make sure you actually draw the actual line. Don't just stop here when you can see that that's the point where the two lines intersect. So draw the whole line. Um, and obviously we can see the point of intersection, but I want to make clear a couple of things. When you're writing this on the test, obviously here's our point of intersection, that red dot there. The point is 2, 1. And there on the test, you'll have to draw both lines, just like we did here. And you'll also have to say that the solution to the system of linear equations is the point 2, 1. So there will be a spot for you to write your answer on the test. So you'll have to write the solution and then write in the point 2, 1. All right, 2 in the x direction, 1 in the y direction. So there you go. That is the first question of the at-home practice. Let's do one more of those, and then I will stop there. So the second question says, solve the system of linear equations graphically. And here are our two linear equations, 2x minus y equals 2 and y equals 3x minus 5. All right, so let's go and do this. 2x minus y equals 2 is not in slope-intercept form. So what we can do is we can put it into slope-intercept form. The way we would do that is subtract 2x from both sides. You would get negative y is equal to negative 2x plus 2, excuse me, if you subtracted 2x from both sides. Now that's almost in slope-intercept form. I just need to now divide each term by this negative 1, this coefficient of my y. If you divide the left-hand side by negative 1, you just end up with y. If you divide the right-hand side by negative 1, you end up with 2x and then minus 2. Divide this by negative 1, divide this by negative 1, changes the signs. So that means that the slope of this line is 2, and the y-intercept is the point 0, comma, negative 2. So let's go ahead and graph that line. All right, so there we go. 0, negative 2. What do we want to go with? Let's go there. 0, negative 2 is this point right there. Slope of 2 means go up 2 over 1. Up 2 over 1. I like doing this a lot, again, just so that I know where each point is. You never know where your second line is going to end up being. So I try to go as far as I can. Sometimes I'll even go either direction. So there you go. There's the points on the line. If I'm going to draw a line, let's go. Whoops, I apologize. I'm going to draw a line there. Going to look like that. Pattern extends on forever. So that's the first line. Y equals 2x minus 2. Now the second line, y equals 3x minus 5, is already in slope-intercept form. We see that that has a slope of 3 and that the y-intercept is 0, comma, negative 5. So again, 2x minus y equals 2, y equals 3x minus 5. All right, so slope is 3, y-intercept is 0, negative 5. Let's go ahead and graph that. Let me graph that, I guess. 0, negative 5 is down here. Slope of 3, up 3, over 1. 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 You can see that we hit at this point, but again on the test, make sure that when you're doing this, you actually, in fact, draw the line that we're looking for. Again, I'll draw this little arrow to signify that the pattern extends on forever. And then you can see this point of intersection here. All right, that point of intersection is the point 3, 4. And if you want, you can always double check that by plugging in 3, 4 into both equations, right? Take 2 times 3 minus 4 and see that you get 2. Plug in 2 for x, 4 for y, and see, excuse me, not 2, 3 for x and 4 for y, and see that you get a true statement here as well. Okay, so what we have is that the solution to this system of linear equations is the point 3, 4, right there. Now, obviously, we like this technique works fine as long as our point is easy to spot. The point of intersection is easy to spot, and as long as the point of intersection is actually on the grid that I'm graphing. And because that doesn't always happen, that's why we need to go to those algebraic methods, if you recall. So that is it for the problems that I am going to do on 2-4B, the at-home practice problems. You can do the other problems, specifically problems numbers 3 and 4, on your own if you'd like, following the same pattern as we just did. The answers to those are in the back of the book.